In this video, we'll talk about reactions of aldehydes and ketones with amines. And before we talk about the reactions, I'll review some amine nomenclature. So if we have an R group bonded to a nitrogen, all amines contain nitrogens. So we have an R group. That R group is a carbon chain bonded to nitrogen with two hydrogens. This is called an alkylamine. And when the nitrogen's bonded to one carbon chain, that's a primary amine. So you might hear that term as well. If we have nitrogen bonded to two carbon chains and one hydrogen, this is still an alkylamine, but this is a secondary amine. And then when nitrogen's bonded to three carbon chains, this is a tertiary amine. So all alkylamines, primary, secondary, and tertiary. If we have an aromatic ring bonded to a nitrogen, we'll say NR2, because these can be hydrogens, these can be carbon chains. This is called an aryl amine. So remember, aryl refers to an aromatic ring. This ring could have other substituents around that benzene ring or that phenyl ring. So this line here to an R group is just to demonstrate that other substituents could be present in different locations. So we'll write a little note here, may have other substituents on the ring. When there is an OH group bonded to a nitrogen, this is called a hydroxylamine. And then if you have two nitrogen groups, like two NH2 groups bonded together by the nitrogen, so the two nitrogens are bonded to each other, this is called a hydrazine. And another example of a hydrazine, let's say we have two nitrogens bonded together. One's bonded to two hydrogens and one's bonded to a hydrogen and a phenyl ring. This name of this molecule would be phenylhydrazine. So that substituent group, the phenyl group, is listed or named before the hydrazine word. So here's some amine nomenclature, and then we will go ahead and, before going through the mechanism, we'll look at the reaction scheme of aldehydes and ketones with amines, a couple of examples, and then the mechanism. So here's a general reaction scheme. And we'll show the reaction scheme with primary amines. So we can start with an aldehyde or ketone. We add an amine. So a primary amine has one R group that is a carbon and then bonded to two hydrogens. Typically heat is added, so that's represented with a delta. And then the product of this reaction, we still have the carbonyl carbon bonded to whatever it's bonded to besides the oxygen. So the other two groups. It now has a double bond to the nitrogen. And then the nitrogen is bonded to an R group. So the nitrogen is no longer bonded to the two hydrogens, but it's bonded to the R group and double bonded to the carbonyl carbon. And then a byproduct is H2O. So let's trace some atoms here. We'll start with the nitrogen. So the R group in the amine and the nitrogen in the amine both end up in this organic product. The hydrogens from the amine end up being bonded to oxygen in H2O. The oxygen in H2O is from the aldehyde or ketone, and then that carbon, the carbonyl carbon, and whatever else it's bonded to besides the oxygen are both in this final product here. And this final product, where we have a carbon double bonded to a nitrogen, this is called an imine. I-M-I-N-E, an imine. Now this reaction isn't very favorable, but to drive it forward, to increase the likelihood of the products forming, heat is added that adds kinetic energy to the reactant, so they're moving around faster, they're more likely to collide with each other for the reaction to occur. So that's why heat is added. And additionally, water is distilled off as a product. So let's write this note here. To drive the reaction forward, heat is added and H2O is distilled off. Distilling off H2O, we're removing a product, and so that takes, or this is an example of Le Chatelier's principle. Where when we have a reaction in equilibrium, if we remove a product, that will encourage the reaction to proceed in the forward direction. So let's go through a couple of examples where we'll just predict the product. Now we'll talk about, you see I'm adding acetic acid here. We'll talk about after a couple of examples why this is, but this is a buffer solution with a pH of 5. So a buffer solution is a solution that can keep a pH pretty stable. So our reagents here, we have a ketone on a cyclohexane ring, so cyclohexanone. And then we have an amine where that nitrogen's bonded to an OH group. So this is a hydroxylamine. And looking at the reaction scheme above, we start with an aldehyde or ketone. We create a double bond to the nitrogen. The hydrogens leave that are directly bonded to the nitrogen, but the nitrogen's still bonded to whatever else it was bonded to in the starting material. So our product here, we still have our carbonyl molecule. We have the carbonyl carbon. Now the carbonyl carbon is double bonded to the nitrogen, which is still bonded to the OH group. And then our byproduct here is H2O. So the H2O molecule is made of the two hydrogens that were bonded to nitrogen and the oxygen from the carbonyl. Let's do one more example. Okay, so we've got our ketone, we have an amine. I drew the carbon structure of the ketone molecule. Where the carbonyl was, that carbon is now double bonded to the nitrogen from the amine. The nitrogen loses the two hydrogens to water, and the nitrogen is bonded to that phenyl ring with the methyl substituent in the para position. So there's our product. We'll talk about the buffer solution in the next video when we go through the mechanism.